So take 3 of the Bohr model. So in this video we're going to discuss the Bohr model, which is from Niels Bohr, and this is a representation of the hydrogen atom. In the nucleus we have protons and neutrons, and in the surrounding area of electron density we have just one electron in the 1s1 position. So let's talk about a bookshelf real quick. If I wanted to raise an item from this ground state to the first bookshelf, I would have to give it enough energy to put it on that bookshelf. What if I only gave it enough energy to raise it halfway and then I let go? It would drop to the ground. I would have to give it enough energy to take it to this bookshelf, and then if I let go, it'll stay on that shelf. Same if I give it enough energy to raise it 2 bookshelves off from the ground state. So that's very much similar to the Bohr model. So let's take a peek at the Bohr model here. And if I were to give this electron enough energy, I could go from n equals 1 to n equals 2. I could go from this first energy level, n equals 1, to the second energy level, n equals 2. So I would have to give the electron energy, right? And then it would be in this state. So this would be the ground state. This would be the excited state. So what would happen after we're in the excited state? Can this electron exist in this excited state forever? No. It will go back to its ground level. So we give it energy to raise it to a higher energy level, and then it will relax and release energy to go back to its ground state. It just so happens that the same energy that it absorbs would be the same energy that it releases. This is why when you give certain, this is why you observe this phenomena in, with fluorescent lighting, those kind of things. You give the energy, and then they release the energy, and they release it in the form of sometimes visible light. So what about raising this electron? Can we raise it to the third energy level? Of course we can. So this electron can actually get enough energy to raise to the third energy level. Of course, it's going to take more energy than this to raise it to the third energy level. But then it will relax and come back to the first energy level. Now here's the tricky part. It may relax all at once, or it may relax in stages. So what's to say that it doesn't relax, go to the second energy level, release some energy, and then continue to relax back to the ground state? Would it also be possible for it to do it all at once, right? So these are all different types of energies that could be absorbed or released. So this is actually, we're going to be calculating the energies that can be absorbed or released, and we can see whether or not they would be in the visible light spectra, the UV spectra, so on and so forth. So just for another example, we can kind of ignore this right now. I'm resetting it up, right, where we have our 1s1 electron. What if it were to be excited to the fourth energy level? Right? So it absorbs energy, goes to the fourth energy level. What are our options? Well, we could relax all the way back down in one shoot, right, in one shot. We could relax one energy level down and then maybe relax 2. We could also relax 2 energy levels down and then relax 1. Or you know what? What if we just took it one level at a time? So we've identified 1, 2, 3, 4, 5, and 6 different levels of transition from n equals 4 to n equals 1. N equals 4 to n equals 3. This is also n equals 4 to n equals 3. N equals 4 to n equals 2. N equals 3 to n equals 2. And n equals 1 to n equals 2. So you can see how it kind of gets a little bit sticky and a little bit in the weeds. We were just doing one transition. So there's a lot of options here. And that's why if you look at your emission spectrum and absorption spectrums for anything more complicated than hydrogen, that's why you see they may have 50 lines, they may have 80 different lines. Those are all the different types of transitions that it makes only in the UV-Vis spectra. That's not even showing you all the transitions that it makes in different ranges, in the ultraviolet spectra, in the IR spectra, so on and so forth. So I'm about to make a second video where I do calculations with you to actually see what these energy transitions are. So thank you so much for watching.